Okay, well, I think we'll go ahead and get started. And for today, or whenever it is you decide that you are going to catch up by seeing what we had missed, you're going to need this flow chart that was handed to you. It has benzene in the middle. Okay, and the way to use this is to determine where it is you're actually starting in any type of problem. Okay, because as we know, as we had illustrated in the center here, that's where we begin with benzene. And as you branch out, it's illustrating all the different catalysts and reactants that would attach molecules onto the benzene ring. And also up here in this upper left-hand corner where we have what's considered as alkyl groups. Those are your methyl, ethyl, isopropyl, propyl groups. Hydroxy, amino, and X is just a variable for the halogens. One of the things that I think would be worth noting is that those top four dashes, the alkyl groups, and then hydroxy, amino, and then the halogens, or X. These are what we call ortho and para directors. Okay? Now, whether you decide to put that on your paper or not, that's entirely up to you. These top four are what we call ortho and para directors, and then this bottom one, a nitro group, is what we call a meta director. Okay? So these top four, again, are ortho and para directors. The bottom one is a meta director. Because the reason that's important is if there's a molecule already on the benzene ring, it's that molecule that is going to determine where your next reactant is going to attach to. So if we were to just start in the middle, and if we want to, for instance, just attach or synthesizing toluene, okay? How we would go about that is we know you would have to begin with your benzene ring, okay? So again, our end result is we're trying to make toluene. So there's our benzene. So as we look on this this flow chart, again, we want to find the variable R, okay? And there's two different ways you can do that. You look at about between 12 and 1 o'clock, you can essentially add an alkene on there, and with an acid catalyst, get that R group attached on there. Okay, that's one way, but probably the more common is, I would say, what, about 830, it says RX and a metal catalyst. So, what would you determine that RX is? What is RX, do you think? Because what is R? Is any alkyl group, okay? Alkyl group and a halogen. So what that means is we had said toluene. It could be any alkyl group. Maybe you want to put a propyl group on there. Well, then you would put letter R is still any alkyl group, which propyl, the propyl derivative is, and then a halogen. But we're just sticking with toluene. So what that means is we would add this R group, which is an alkyl group, because we're looking for toluene. So there's really no reason to make this any longer than it has to be. So we can write it as this. Okay. It doesn't have to be methyl chloride. It could be methyl iodide, it could be methyl bromide, any one of those, as long as you have an alkyl group and a halogen. So if we're not comfortable with this molecular formula, what's a different way we can write that instead? Use your structural formula. And in this case, it's not such a big deal. Well, I shouldn't say big deal. But what I mean by that is notice that this is not attaching to anything. It's when this gets attached to the ring is where it gets to be a little more confusing. So here is your molecular formula. Well, then here, of course, is your structural formula. So if you wanted to use that instead, there's absolutely nothing wrong with illustrating that. So what is it that we're going to do to get this toluene on here? According to this, we have to use what type of catalyst? You have to use what's called a metal catalyst. So in that case, we'll just use, I don't know, nickel chloride. Okay, that is a metal catalyst. And typically, the experiences that we've had in this class, if you have methyl chloride within your metal catalyst, it's probably going to have chlorine in it, or chloride ion as well. Doesn't matter. Iron chloride, aluminum chloride, iron, or I said that twice. Nickel chloride, iron chloride, aluminum chloride, cobalt chloride, any one of those metal catalysts we'd want to add in here to then get this attached. Okay, so this reaction is going to proceed. So one thing to ask yourself, when we're looking at this benzene ring, it's got what inside of alternating double bonds? And when we talk about double bonds, how are these types of double bonds different than the aliphatic hydrocarbons? The benzene ring is stronger. Yes, this is a very stable ring structure, unlike your aliphatic hydrocarbons, which have weak pi bonds in them, which are easily broken. So the difference is you have to have a metal catalyst for this because this is such a stable structure. Where your aliphatic hydrocarbons, you do not have to have that catalyst. So as we look at this, we've got our situations just right. We started with our benzene ring here. We've got our R and our X, our alkyl group, and our halogen. We've got our metal catalyst, so everything is just right now. So what do we see happening? This reaction will proceed, and our end result will now be what? Toluene. That's what we were looking for. Only toluene? Only toluene. Well, what was on here? Yeah, it's an HCl. Yeah, now you have plus HCl. Yep. So it's not like it disappears, but I get what you're saying. So one of the things to think about is if we got a word problem and we have this mechanism we need to deal with, if you're starting with toluene, okay, well, then we're no longer here in the center. We got to branch out to see what it is we're actually looking for. So toluene could be, the most common spot is down here because it's an R group, which means alkyl. Okay, we'll get a little further into adding alkenes on here to illustrate this mechanism up on that side. But this is one of the things that we had illustrated yesterday. Okay, in other words, how is the reaction of chlorine and toluene different with a metal catalyst versus an addition of heat? Okay, so what we've illustrated is how to make toluene. So now, hopefully what we went over yesterday, this would reinforce this to look at, all right, well, here's our toluene. So again, we're not starting here in the center because we're not beginning with benzene. So we need to find, here's our toluene. It just says R, but again, R means any alkyl group, and that's what we have here. So this starts to break apart according to this flow chart here. If we're adding heat, okay, well, you're going to have R and X. And if we're going to use a metal catalyst again, why do we see two different products on here? Because what did we say earlier about these guys up here? What does an alkyl group illustrate? If that alkyl group is on here and you're not adding heat, but rather a different catalyst, this is going to, what I want to say, not mandate or dictate, but it's going to force whatever it is you're adding on there into one of two positions, which is right here and here. Although I think we ran out of paper, but or out of space. But if this is R and X here, we know that's an ortho position with this X. So then the other aspect, where would that X be on this ring?
Yeah,
No. Okay, again, what type of directors are these up here?
Oh, it would go on either the ortho or the para.
Right, so if we have the ortho position here, where's the para position on here? We just ran out of paper, I think, or room. It would be straight across from it in the number 4 spot. Okay, so that's what that would be. The para position, according to here, would be on carbon number 4. Okay, now you might be thinking, well, if we have this R and X here attached, well, why don't we just skip a couple steps? Here we have an R and an X as well. Okay, this mechanism doesn't work where you just take in an alkyl group and a halogen and just attaching it right on there like that. It just doesn't work that way. First of all, you have to have an alkyl group on there and then add your halogen. I know it kind of sounds redundant, but that's how and why this flow chart is supposed to help you then. So as we had done yesterday, okay, you tell me, heat or metal catalyst? You pick one of those two. Okay, so if we add heat and a halogen to this, are we going to get one or two products? Just going to get one. And pick a halogen. So if we're going to add some bromine to this, okay, and some heat, I'm kind of running out of room over here. What's this bromine going to do on this benzene ring because we're adding heat instead of a metal catalyst? You said one product. That's right. Right. So when you're doing this, don't do this. We said yesterday, why is that wrong? Because now you're illustrating carbon having 5 bonds. I can't do that. Okay? Because one of the things I can almost guarantee you in some of these word problems, we're going to say start with toluene or ethyl benzene or propyl benzene and add a halogen to it with heat. And a very common mistake then, we'll just say an ethyl group. And that's how we learn with this. So ethyl group means what? C2H what? That's ethane.
An ethyl group, yeah, it's 5.
Yep. So then what can happen, again, for the same thing, you're going to add some iodine here instead. And when this proceeds with your heat, if we're not paying attention, might say, oh, C2H5I. Same problem that we have up there. When you do that, you have to take a hydrogen off of there. So, yes, that would be correct. Yep. So now notice that that's how this flow chart is supposed to help us. You want to look at where you're at. Are you starting with benzene? Are you starting with something other than benzene? Okay. So in this case, we started with benzene. We had an alkyl group with a halogen, or Rx, our metal catalyst. That gave us our toluene. Now, if we have our toluene and instead of adding heat, we're going to add another metal catalyst. And let's just, for argument's sake, say, we've got our toluene here. Again, in our previous example, we added heat. Now we're going to use a a metal catalyst, and we have already illustrated that. So let's go ahead and add some, well, just chlorine is fine. And again, some nickel chloride. Now, when you look at this, if this is where you were starting, okay, well, we're not here, we're already past that stage, so we need to find where R is. So it's either up here or down here. But we don't show you what happens after this. I mean, it would be the very same as what you're looking at down here. So R, there it is right there, or this alkyl group. Then we're going to add a halogen with a metal catalyst. We just have aluminum on there. It'd be the same as nickel on here. So now when this reaction proceeds, what do we get down here? One or two products? You get two products. In other words, one chlorine will attach where in reference to here? Either here or here for your ortho position. That's one. And then where's the other one at? Straight down here. And you do need to illustrate both of them. They do occur in equal amounts. I want to say there is a meta position, but I think that's less than 5%. Correct. Okay. So that's a lot of information, okay, in a short amount of time. Now, this may seem difficult now because it's the first time you've seen anything like this. When you're a freshman, we talked about what benzene was. You probably just drew the structure. Then, as juniors for general chemistry, maybe just did the same thing, but just named some organic compounds. Now we're taking that one step further. You're taking the benzene and going through the mechanisms or reactions that would follow. Are we on the bus so far? Again, that's a lot of information in a short amount of time. So, all right, we will catch up to you next time. On the board, it said we're supposed to have a paper that was going to be assigned, but because of events where people are gone for one reason or another, we'll address that when we come back on Tuesday.